You ever just stop and wonder how the internet actually works? I mean, how can these massive websites handle millions of us all at the same time without just, falling over? Well, let's get into it because the answer is one of the most important but totally invisible heroes of the online world, the load balancer. So picture this. Your favorite site is dropping a new product, or maybe streaming a huge live event. Millions of people, you included, are trying to get on right at the same second. All that traffic, all those requests are all pointed at one single destination. What's going to happen? Yup, that's what. The server just gets completely swamped and gives up. It's basically a digital traffic jam that shuts the whole highway down. For you, it's that frustrating error page. And for the company, it's an absolute disaster. And this isn't just some made-up scenario, right? This is the fundamental problem of the modern internet. It's a constant, massive traffic jam that has to be managed every second of every day. I mean, really think about it. Every time you do a Google search, or binge a show on Netflix, or add something to your Amazon cart, you're one of millions of people doing that exact same thing at that exact same moment. There is no way a single server could ever keep up with that. So, how do they pull it off? Well, the solution is actually pretty genius. They have a kind of digital traffic controller working behind the scenes, making sure everything flows smoothly. So let's go meet this traffic controller. And here it is. This is the hero of our story, the load balancer. Its job sounds simple, but it is absolutely critical. It takes all that incoming traffic and just spreads the work out. It distributes it across a whole army of servers so no single one has to do all the heavy lifting. This analogy is pretty much perfect. The load balancer really is like a traffic cop at a super busy intersection. It sees all the incoming requests, those are the cars, and it intelligently points each one down the clearest path, making sure no single road, or in our case, no single server gets totally gridlocked. Okay, so how does our traffic cop decide where to send everybody? It's not just random pointing, right? It actually follows a specific set of rules or algorithms. Think of it like a playbook for managing traffic. So, the simplest and maybe most common method is called round robin. It works exactly like you're dealing a deck of cards. The first request, it goes to server 1, the second to server 2, third to server 3, and when it gets to the end of the line, it just loops right back around to the beginning. It's simple, it's fair, and for a lot of situations, it's incredibly effective. But, one size doesn't fit all. Round robin isn't always the best play. For example, there's a smarter method called least connections. It actually looks to see which server is the least busy at that moment and sends the new traffic there. And then you have something called IP hash, which is super important for things like online shopping. It makes sure you always get sent to the same server so that stuff in your shopping cart doesn't just vanish. Okay, this all sounds pretty good, but it raises a really important question. What happens if our traffic cop sends a car down a road that suddenly has a giant sinkhole in it? I mean, what if one of those servers just dies? This is where the load balancer really earns its hero cape. See, it's constantly checking in on its servers, kind of pinging them and asking, hey, you okay over there? If a server doesn't respond correctly, boom, the load balancer immediately takes it out of the lineup and sends its traffic to the other healthy servers. And the most important part, you, the user, never have a clue that anything went wrong. That's what we call fault tolerance. It just works. So we know what they do and we know how they do it, but what are these things? Are they like physical boxes with blinking lights or just pieces of software? Well, the answer to that is yes. Let's break down the different types. So, back in the day, load balancers were these dedicated, really powerful physical machines that you'd find racked up in a big data center. But today, it's way more common to use software-based load balancers, like Nginx or HA Proxy. These can run on just standard servers, which gives you a ton more flexibility. And of course, now we live in the age of the cloud, and load balancing is just a fundamental service. All the big players, AWS, Azure, Google, they all offer these incredibly powerful load balancers you can set up with just a few clicks. And the really cool part, their killer feature, is that they can automatically scale. If traffic suddenly spikes, they'll spin up more servers on the fly and balance the load perfectly. All right, so we've gone through the what, the how, and the where, but let's bring this all home. Why is this technology so important? Why does it matter so much to our daily digital lives? It really all boils down to this. Without load balancing, the internet as we know it just wouldn't exist. There'd be no massive social media sites, no global streaming services. Everything would be slower, way less reliable, and constantly crashing. This is the tech that allows for the incredible scale, the speed, and that always-on feeling we just expect from everything online now. So think about this. The next time you go to watch a video on YouTube, remember that your request, your click, doesn't go straight to a YouTube video server. No. The very first place it goes is to a load balancer. It's a silent, unseen gatekeeper that, in a fraction of a second, checks thousands of possible routes and sends you down the absolute fastest and most reliable one. And that kind of makes you think, doesn't it? Load balancers are just one piece of this incredible invisible puzzle. What other unsung heroes are out there, working tirelessly behind the scenes every single second just to make our digital world feel so seamless?